Yes.
All right. So this works out to, I believe, is 192.
Yeah.
Right? Now, the reason for this question is that you have to square the 4 first. You cannot go 3 times 4, 4 3s are 12, and then cube that. No, that is wrong. You have to cube the 4 first. So what's 4 cubed?
64.
64 times 3 is 192, right? Then we have over here 4 2s are 8, x to 3 and 3 is 6, right? You add the indices. Over here you add your indices, so this is x to the 8. Over here 2 2s are 4, and you add your indices, so 3 and 2 is 5. Over here you subtract your indices, so 5 minus 3 is 2, 6 squared, right? And 6 is a 36 if you want to go to that step, but I would have accepted 6 squared. I don't know what the answers have though. 4 minus 7 is x to the negative 3, or 1 over x cubed, right? This is 1. Anything to the power of 0 is 1. So this would be negative 1, because this inside here is to the power of 0. So that means that inside here ends up being 1. And then you have the negative sign in front of it. So that ends up being negative 1. Let me know if you see how fast I cutting this through. I might get some wrong. So let me know if I'm making any errors, right? Of course, you had to multiply 4 times 3. So 4 3s are 12, is it? Right? In this case, I have to multiply the 4 by the 2. So 4 2s are 8. And then the 4 by the y. So y to the 4. Shazay, you got that one?
Yes, sir.
Right, so I know that was a mistake you were making last time. 2 into 2, 1, so I have 3 there, and then 7 minus 4 is 3, so I have 3x cubed, right? 4 into 4, 1, 4 into 8 is 2, and then 5 minus 2 is 3, so I have 2x cubed, right? Ooh, now they're getting a little bit tricky, so now this here will give me 2 squared c squared d, 4 2s are 8, times C5 D5, right? So let me know if I'm going too fast for you all, right? So now that means that now I could just add my C's. So 2 and 5 is C to the 7, 8 and 5 is D to the 13, and then I can leave the 2 squared over here. So let me just write that out a little better. 2 squared, C to the 7, D to the 13. You all got that one?
Yeah.
Let me know if I'm doing anything wrong. So this is 2 to the 4. Alright, now let me just write it next to it so it'll be easier to see. So this is 2 to the 4, F to the 4, G to the 16, times F to the 6, G to the 6. So what you're going to get is 2 to the 4. I add my F's, so 6 and 4 is 10. F to the 10. And then I add my G's, so 16 and 4 is 20, and 2 is G to the 22. Was that the answer?
Yes.
Alright, thank you. So over here, x into x1, so x to the 4 will remain. 2 and y to the 4 will remain, so x4, y4. Right? Same thing here, x will remain, x to the 1, and then y to the 1 will remain. So I have x, y. Right? I'm just gonna cut through. Well, actually, no, I'll go in order just in case, right? Now everything has to be cubed inside of here. Ooh, this is a tough one. Let's see. Well, how do we do this? Oh, there is a law. Remember, there's a law that a over b to the m is equal to a to the m over b to the m. That is the law, right?
Yes.
So that is the same thing there. So that means that all of this will be to the power of 3, and all of this will be to the power of 3. So that means that 3 is going to be multiplied by everything inside of here. So that is 4 to the 3, and then x to the 15, y to the 3, all over 16 to the 3, x to the 3, y to the 4 times 3. 4 3s are 12, right? So what I'm going to get is, well, this 16 to the 3, 4 4s are 16, so that could actually be replaced by 4 squared to the power of 3, and 4 squared to the power of 3, 3 2s are 6, is 4 to the 6th. So I can actually replace this 16 here by 4 to the 6th. Everybody understand how I get our 4 to the 6th? Right? Right? So 4 to the 3 could go into 4 to the 6, and I'll have 4 to the 3 remaining down here. X to the 3, one up here, will go into x to the 15, and I'll have x to the 12 remaining. And then y to the 3 will get into 1, and then 12 minus 3, that is y to the 9, 10, 11, 12, 9. Right? So now what will I have in my numerator? I'll have x to the 12, and then my denominator I'll have 4 to the 3, y to the 9. Is that what you guys got?
I didn't get that one.
What did you get?
Yeah.
I didn't finish it.
Oh, you didn't finish it? What about you, Shazzy?
I got x to the 12 divided by y to the negative.
Oh, y to the... Alright, so the reason why, and we see here that we have y to the 3 all over y to the 12, right? So we know the rule is y to the 3 minus 12, which is y to the negative 9. So that is the rule. But the problem is that that is kind of when you bring this y to the 12 up. When you bring the y to the 12 up, it becomes y to the negative 12. Right? So really and truly, this is 1 over y to the power of 9, isn't it? Yeah?
Yes, sir.
So you took this and you plug it straight inside your denominator, but no. Right? That is why instead of doing this, I just said, you know what? Y into y 1, 3y is 1, and then remove 3y's from here to get y to the 9. Make sense?
Yes, sir.
Right? So that's a lovely little mistake there. That is a beautiful mistake to make, because you know you learn important lessons from these things, right? Right. So same thing. Just now, let me just check with the answers in case I got it wrong. Right? X to the 12, y to the 9, and they expanded the 4 to the 3 to get a 64, but I don't like that. I leave it as the index, right? Same thing here. This 4 is going to be multiplied by every single thing. So that's 5 to the power of 4, x to the 4 3s are 12, y to the 4, all over 20 to the power of 4, x to the 4, y to the 5 4s are 20. Now I could do the same thing here. You can see that I could take this this 20. Can I put it to 5? No, because 5 squared is 25. Right? So I gotta leave that 20 there for now. Yeah? 5 4s are 20 though, so I can have 5 times 4. Right. Yeah. So I can have 5 times 4 to the power of 4, eh? We all agree with that? So if 5 times 4 to the power of 4, that is 5 to the 4 times 4 to the 4, eh?
Yeah.
Yeah? So instead of having this 20, I can have 5 to the 4 times 4 to the 4. And that way, these 5 to the 4s could cancel, right? This 4 will cancel with this 12, and how much will remain? 8. X to the 8. And then this 4 will cancel with this 20, and how much will remain? Y to the 16. So now what will I have? X to the 8 in the numerator, everything else cancels to 1. And in the denominator, I gotta have 4 to the 4, y to the 16. You make the same minus mistake here again?
Yes, yeah.
Yeah, so you was using the law. You can see that I am using the law, you know. I kind of using two laws, but I also using kind of common sense as well. Because remember when we proved the laws, y to the 4 divided by y to the 20, that is really 4y's being divided by 20y's. Dot, 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 right? So I can literally cross off these 4y's with these 4y's and have whatever remaining as my answer. You understand?
Yes, sir.
Right. So you could tell there that you could use a little bit of basic knowledge. That's how we proved the laws of indices in the first place. So the laws of indices isn't just about learning it, it's about understanding it, right? Of course, this here is 1 over y to the 7. This here is 1 over 7 squared. This here, what is this? This, remember the rule is a to the negative m is equal to 1 over a to the m. So I have to take this negative 5, and I have to put a negative sign in front of it. Therefore, 1 over x to the negative 5 is equal to x to the minus m, which is negative 5. So the answer is x to the power of 5. You all got that one?
No.
Yes, sir.
Alright, yes, but why didn't you get that one?
I don't know what to bring it, but I have to look it.
But you understand what I just did?
Yes, sir.
You sure?
Yeah.
Number 22 is the same kind of business. Number 22 is if we bring this to the numerator, it would be 2 to the minus m, which will be 2 to the 4. You got that, Scotia?
Not this.
No, but you understand what you did wrong?
Yeah.
You understand what I do?
Mm-hmm.
That's the most important part. So of course this is 5 plus minus 1, which is 5 minus 1, which is x to the 4. This here is just simply 1 over x to the 6. This here is 9 plus minus 7, which is 9 minus 7, which is x squared. Over here, all of these are added, right? Because they're all being multiplied. So you could add 6 and 4 is 10 on this side, and 10 is being added to minus 13. So the answer is j to the minus 3. You all got that one?
Yes, sir.
Nice.
Yes, sir.
Over here, we could use when it have negative indices that doesn't like to do the canceling thing like what we were doing before, because the negative indices could always mess you up when it comes to canceling. So before we had a positive indices, it was easy to cancel. It's easy to see that 1 could go into 8, but it's not easy to see how negative 1 is going to negative 8. So I will just use my law, negative 1, which is the top indice, minus the bottom indice, which is negative 8. And that is x to the power of negative 1 plus 8, which is x to the power of positive 7, and that is your answer. You all got that one?
Yes, sir.
Nice. So that's 52 and 13. Can 13 go into 52?
Yeah.
How 13 is going to 52? By 2? By 3? By 4? By 4.
Yeah.
Alright, so that is 4. Right? And of course, so we have 4 on the top, and let's just work with the x's now. So I have 4 on the side here, multiply by, and I'll do the indices for the x's, x to the 6 minus negative 7. So that is equals to 4 times x to the 6 plus 7, which is 4 x to the 13. You all got that one?
No, but I made a small mistake, but
The negative.
yeah.
Alright, yeah. So you went 6 minus 7 minus 1. Right. Now you see here I have the top index, which is 6. That is the M, the top, right? And then the bottom is negative 7, and I'll put that in brackets. And then I'll make sure I have the minus the top from the bottom, right? Or the bottom from the top. So those brackets there really help you out. Over here, you're just adding everything because everything being multiplied, right? So everything is being added here. So I could add negative 3 plus negative 3. That is negative 6. So now I'll have negative 6 plus 2 is f to the negative 4. Get that?
Yes, sir.
Nice.
Yes.
Same thing here. Because of the negatives means that I will use my law. Negative 4 is the top one. Negative 9 is the underneath one. And I had a minus them. So that means that I'll have x to the negative 4 plus 9, which is x to the positive 5. 12, 1, 12, 2 is a 24. Same thing, I have this negative business here. So I'll go, that's 2 multiplied by x to the 6 minus the minus 8, right? Which is 2 times x to the 6 and 8 is how much? 6 plus 8, that's 22, which is 2x to the power of 22. No, sorry, 12. Hear me, 22. 12, right? No, it's 14, it's not 12. Yeah, sorry, I'm teaching since 9 this morning. All you does always get me on my last brain cells. Yeah? So you all have to correct my mistakes, please, because it's been a long day, right? 3 into 12 is 4. Of course, this x could go, so that'll be 1. And when I go into 6, I'll have x to the 4th remaining under here. And then the negative 3's I wouldn't know about. So let me just split it up, right? So I'll pull out the 1 over 4x to the 4. So I know we have that. And that being multiplied by, and then I'll work out the y's now. So the y, well, is multiplied by y to the negative 3 over y cubed, right? So instead of having that, I will put y to the negative 3 minus the underneath one, which is 3. So that is 1 over 4x to the 4th times y to the negative 6, which is 1 over 4x to the 4th times 1 over y to the 6th, which is 1 over 4x to the 4th y to the 6th. You all got that one?
Yes.
So that one I just left it as
You left it as this? Yeah?
yeah.
Alright, that's fine. Well, once you got it. I always like to make everything positive. I'm a positive kind of guy. So this here will expand and become 2 to the power of negative 2, right? X to the power of negative 2 times 3. 3 2's are 6, that's negative 6. Y 3 2's are 6 again, so that is y to the positive 6. You all got that? Why?
No.
Why?
I put y and 6 down by 4x to the positive 6.
No. Are we doing this one here? No, I'm doing this one. Is that one you're doing?
Yeah.
I don't understand how. All I did was multiply this 2 by the 2 to the power of 1 to get 2 to the negative 2. I multiply this negative 2 by the 3 to get x to the negative 6. and then this negative 2 by this negative 3 to get y to the positive 6, right? And if I want, I could go one step further and say that this is y to the 6 all over 2 squared x to the 6.
Oh, wait. Okay, yeah.
I think you're looking at, so you got it?
I get the original answer, yeah, but when I was looking at all the answers, it looked like for all of them that was negative, it made them positive.
Right. It's always good manners in maths to be positive, you know? So over here, 2 into 2, 1, 2 into 8, 4. This will go into this and I'll get x cubed, is it? 7 minus 4, right? And then this will go into this, but because of that negative there, I will do it separately. So 1 over 4x cubed times y to the negative 4 over y cubed is y to the negative 4 minus 3. The negative 4 minus 3 is 1 over 4x cubed y to the negative 7, which is 1 over 4x cubed y7. You all got this one? No. Why would it not be negative 3? Because this is positive 3, yeah? So let me do that separately, just for you to see. We have y to the negative 4 all over y to the positive 3, right? So I'll put the y, I'll put my first indice is negative 4, my second indice is positive 3, and I put in a minus between them, eh?
Yeah.
So you understand why it wouldn't be, so you went minus negative 3. So you get like y to the 1 or minus 1 or something. So
I went for the 4x.
Oh, for the 4x.
Yeah.
Well, the 4x. Yeah, it'll be negative 3, but it would that negative 3, and you made the same mistake that Shazay made earlier. It'll be negative 3, but that negative 3 would not be in the denominator. That negative 3 is if you were to take the 7 and bring it above. So it would now be 4 minus 7 to give you negative 3. You understand?
Yeah.
Right? But the thing is that when you're leaving it there, you could just simply cross it out like that. Because x to the negative 3 is 1 over x cubed, eh?
Yes, sir.
And at the end of the day, same thing, you have 4 x's up here and you have 7 x's down here, and then you can just cancel 4 with 4 and you have 3 remaining, eh?
Yeah.
Alright, so you understand? So be careful with that. You could very well use the law to work it out, but remember what the law does is it takes this 7 and it brings it up here. Yeah, that's what it does. So that law would not be, that law would occur in the numerator, but it would not occur in the denominator. You understand?
Yes, sir.
Right. Because you're bringing everything to the numerator. Let me just use this, so I'll get a little space. So this is simply a matter of multiplying throughout. This 3 times this 1 will give me 4 cubed. This 3 times this 4, 4 3s are 12. And then this 3 times this negative 4 is y to the negative 12. And if you want, you could put it in the denominator, y to the 12. Everybody got that one? You did not get that one. What did you do wrong?
I'm not sure, but I can't do this.
Right, but what you get this?
I got 1.4x of y to the negative 1.
1.4x?
Yeah, so I don't know what happened.
What? How you managed to do that?
I I have no idea.
That is magical, girl. You do some magic there. You understand why I do, right?
Yeah.
Nice. And I'm really happy that you guys are making these mistakes. Yeah. So these, so I'm hoping that you all are learning how to use the laws of indices a little bit better, right? So we have here now number 36. Now, everything in here is being multiplied by everything in here, right? So I could literally just remove the brackets and say 5 times x squared times y times 2 times x 4 times y to the negative 3. And you notice I didn't go 5 times this and 5 because it have no addition in here. It have no addition, it have no subtraction, right? Remember, multiplication, just join everybody into one unit. So this is one unit being multiplied by each other. This is one unit being multiplied by each other. But because the two of them being multiplied means that all of them could be seen as one unit here. So I just removed my brackets. Right? So now I can say, well, all right, the 5 times the 2 is the 10. Right? The x squared times x4 is x to the 6. Right? And then the y times, so this is 1 plus minus 3, which is y to the negative 2, is it? 1 minus 3 is negative 2. So you got that one?
Yeah.
Lovely. Shizzy, how you felt about that one?
I get that.
You got that one wrong? Because why? You did distributive law or something?
Oh wait, no. When I have 1 plus negative 3, I have to do it so negative 3
Okay. Alright, well that's not see. That's not see. That's just a little thing error. So we could multiply this negative 4 by everybody inside of there. But we don't really have to, we could actually just start cancelling off one time. Yeah? Because this a squared will go to 1. And this, this here will be a to the 1, right? This here will go to 1. And this here will be b to the 1. Right? This c to the 0, that is actually 1. So I'll just be left with c cubed down here. So what do I have left now? Negative 7 alone in the numerator. All over 3 a b c cubed. Right? And all of that is to the power of negative 4. So now I could start to multiply the negative 4 throughout, and it's a lot easier of a job. Will you understand how I got from there to there? Yeah, Shizzy, you okay?
Yes.
So now if I multiply the negative 4, I'll have negative 7 to the power of negative 4 all over 3 to the power of negative 4, a to the negative 4, b to the negative 4, and then c to the negative 4 times 3, which is 12. So a lot of negatives. Did you all get something like this?
No.
Scotia, how about you?
No.
Let me see what the answer have here. 57. Ooh. Alright, well they just flipped it over. That is that. But did you get this answer that they have here? Alright. Well, all that they did was they flip it over. Now I'm not going to expand the numbers. They expanded the numbers. Right? But I'm not going to expand the numbers. Fire for that. The numbers just look easier with it, right? So at the end of the day, you have to remember in terms of fractions that this is negative 7 minus to the power of minus 4 over 1 multiplied by 1 all over all of this madness here. 3, negative 4, a, negative 4, b, negative 4, c, negative 12. Right? So I could actually flip this to get Well, you know, negative 7 to the power of negative 4 is really 1 all over negative 7 to the power of 4. Yeah? Now, negative 7 to the power of 4 is going to be a positive number, eh? Because you're multiplying negative 7 4 times. That's an even number of times. So you will end up get a positive number down here, right? Multiply by, and then I could flip all of these guys to get 3 to the 4, A to the 4, B to the 4, C to the positive 12 because of my laws of indices. So that is how they ended up getting, so they positivize everything. So they ended up getting 3 to the 4, A to the 4, B to the 4, C to the 12, all over negative 7 to the 4. And of course, I didn't expand the numbers, but they expanded the numbers down here. Alright, so negative, 3 to the 4 is 81, I guess, and negative 7 to the power of 4 is that positive big number down there. So what did you all do wrong? You all understand what I did here? Any questions?
I understand.
Shazzy?
Yes, sir.
Alright, so so we have this one here, and I could just do the same thing, this into this one, and I'll have A to the 1 left here, this into this one, and I'll have B to the 1 left here, and of course C to the 0 is just 1, so I'll just have C to the 7 left down there, right? And well, negative 2, okay, I do not know that. So therefore what I'm going to end up with is negative 2A on the numerator, right, divided by 3B C to the 7 in the denominator, all to the power of negative 2. So that is negative 2 to the power of negative 2, A to the power of negative 2. You know what? Could we do that? Yeah, we could do that. Instead of actually multiplying out the negative 2, what if I did this? 1 over negative 2A over 3BC to the 7 all to the power of positive 2. What do you all think about that? All I did there was I said that A to the negative M, and this is A, inside the brackets is AN. Yeah, so A to the negative M is equal to 1 over A, 1 over A to the M, and? Shazay, you understand?
Yes.
Right. So now I could just multiply by positive 2. So 1 all over negative 2 squared A squared. So everything nice and positive there. All over 3 squared B squared C to the 14. I'm multiplying 2 throughout, right? So if you're dividing by a fraction, then you invert and multiply. So now you'll have 3 squared B squared C to the 14 on top. I just inverting the fraction. This have nothing to do with the indices. A squared. I just invert the fraction and multiply by the numerator. When you divide by a fraction, you have to invert and multiply that denominator there. So therefore this here is your answer. 3 squared B squared C to the negative 14, negative 2 squared A squared. You all got anything close to that?
No, sir.
Or they wasn't checking to see that it have answers here? B squared C to the 14. Huh?
Exactly the answers.
Alright. Did you, well, the purpose when it have answers, the purpose is when you check the answers and you get it wrong, you're supposed to go back and find out why. That is the purpose of having answers. Yeah? So do you understand what I did here?
Yes, sir.
Alright, you sure?
Yeah.
Alright. So that was the first 40. Well, basically almost 40 there. Whew. Real questions I give all your boy. Don't worry, today I'm not giving all you no homework, so I could relax for the weekend, right? Right, so simplify your answer. Your answer should contain only positive exponents, as is good mathematical manners. So 2 2s are 4 m to the power of 5. Are they cool with that?
Yes.
Alright, this one here is 2 m to the power of 1. Okay?
Yes.
4 2s are 8 r to the power of -1, yeah? Right, but that's not correct because they want positive integers only, so the answer is 8 over r. And?
Yeah.
This is r to the 1, which is r. So we want positive integers only, right? Over here, 4 2s are 8. Wait, didn't we end up with a negative integer somewhere? I didn't know. Okay. So 4 2s are 8. N to the power of 1, yeah?
Yeah.
I'm just gonna keep going. 4 2s are 8. K to the power of 5. Let me know when to stop. Let me know when you get it wrong. Huh?
I said yes, sir.
Okay. Let me know if you get it wrong. I want to know if you get it wrong, right? 2 times 2 is 4. X 3 minus 1, well 3 plus minus 1 is x squared, and y is -3. -3 plus 3 is y to the 0, so the y is cancelling off there. So it'll actually be y to the 0, which is 1. So the actual answer is 4x squared. You all got that?
Yes, sir.
Good. Nice. I know these were a little bit easy. 2 3s are 6. 6 y squared x. There's nothing much you could do about that, right? 4, well, you had the 4 there. The 4 is not multiplied by any other number. You have v cubed, v to the power of 1, that is v to the power of 4 u squared, okay?
Yes, sir.
Alright, I have here 4 3s are 12. A to the 3 minus 4 is a to the -1, right? And b also to the -1, because that is 2 plus minus 3, which is 2 minus 3. Okay? So now this is 12 all over ab. You all get that one?
Yes, sir.
I mean, I'm glad that you get correct, but read your question. Right? Read your question. But I'm glad that you do the operation correctly, though. X to the 5th, y to the -4 plus 2 is -2. That means it's x to the 5 all over y squared. Right? This here is just 1. Right? This here is 1 all over 2x squared to the +4. Right? And then I could expand 1 all over 2 to the 4. 4 2s are 8x to the power of 8. You can leave it like that, or you can expand that too if you wanted to. 4 to the power of 4, because that r to the 0 is 1. So this is 4 to the power of 4, and I don't know what that is, but you could figure that out. This is 4 squared. A to the 3 2s are 6. So 4 4s are 16. A is 6. This here is 3 to the power of 4. K to the 4 4s are 16. And well, you can leave it like that, or you could expand the 3 if you want to. This here is just simply 1 all over 4xy. You all got this now? One, number 16?
Yes, sir.
Yes, sir.
Right. And look, we have... Oh, these are not answers. These are more questions. I thought we were done. This here is just simply 1 over 2b to the 4. Look cool with that?
Yes, sir.
This one here, we could see that we can expand it first, so that's x to the 4, y to the negative 2, which is x to the 4 over y squared. Right. This here, we could just simply put this as 1 all over 2x to the 4 y to the negative 3. Remember, now all of this is going to be to the power of positive 1. Yeah? So you're okay with this step?
Yes, sir.
Right, but we want positive integers only. So now that we got rid of this negative 1 here, we can remove the brackets now because it's all to the power of positive 1. So I now have 1 all over 2x to the 4, and that's being multiplied by 1 over y to the negative 3. And
Yes, sir.
so therefore that is 1 over 2x to the 4 multiplied by y cubed, which is y cubed all over 2x to the 4. You all got that?
Yes, sir.
Alright, we have this one here. This one is just simply 1 over 3m all squared. You could expand it to get 1 over 3 3s are 9m squared. Right? This one here will just simply be, this will cancel with this, and you'll get 1 over 2r. Over here, I could keep the quarter on the outside, multiply by x to the negative 1 minus 4. Right? This is the top indice, this is the underneath indice. I keep saying indice, but the word is index. There is no such thing as indice. There is indices, right? Which is plural for index. And I don't know why I keep saying indice, like if it's a singular. Something wrong with my brain, right? So hard luck there, it's index, right? So now I'll have a quarter x to the negative 5 minus 4 minus 1 minus 4 minus 5, which is 1 over 4x to the 5th, right? So you see how when you have negative numbers, it's kind of tricky to do the cancelling of thing, because look, you end up with x to the 5th. You understand? So so be careful there. These 3's gone, this and this gone, I'll just end up with n to the power of 1. These gone, I'll just end up with a half. Easy peasy. This 3, I'll leave this 3 there, and I'll go m to the negative 4 minus 3. Alright, remember this is the bottom index, this is the top index. Alright, and I have the minus in between. So now, that gives me 3 times m to the negative 7, which means that I now have 3 all over m to the 7. This one here looks tricky, but I'm sure it's not. This will go into this, I'll get x squared. I have these negatives here, and I have these negatives here that I'll have to work out. So let's split it up. I have 2 over 3 times x squared over 1 times the y's, which will be y to the negative 4 minus negative 3, the index there, and that'll be times z to the negative 3 minus positive 4, because the underneath 4 is positive. So that means that I'll have 2 over 3 times x squared times, what is this? That is negative 4 plus 3, which is y to the negative 1. And then this is times z to the power of negative 3 minus 4 is negative 7. So that means that I'll have 2x squared all over 3yz to the 7. I'll get through with this one?
Yes, sir.
Alright. Okay. I was expecting, well, this is 1, so this gone. This 4 and this 4 is gone. Right? And now I just left with that. And of course I could bring the y underneath. So I'll end up with z cube all over x y squared. So I'll just leave the z cube up there and I'll take the y to the minus 2 and brought it to the denominator. And that is what I end up with. Yeah? You all got that?
No, sir.
Why? Where you do wrong? So you could see here that if it is in terms of indices, if you're taking something from the numerator to the denominator or from the denominator to the numerator, all you really need to do is change the sign of the index, right? And the reason why is because of this rule. There's a rule, right? You just change the sign of the index, right? So all I did was, well, this x to the 0, well, that's 1. Yeah, that's 1. That I canceling with nothing. That is 1, right? This 4 and this 4 cancels. I have this x remaining. So I'll leave the z cube on top and I just bring this here to the denominator to give me that. What you all did wrong?
I made a dumb mistake, but I'm sad.
Okay, you sure? What about you, Shazzy?
So, I actually, when I see 4x to the power 0, I just put 1 right there, and I leave the other 4x at the bottom of the equation.
So you cancel out the x's?
No, I cancel out 4x to the power 0 and just put 1, and I leave the next 4x there.
Oh, okay, so you didn't cancel the 4's.
Most.
Right. With this one here, well, this k will go into this k to give me k to the cube, right? It's just the j's I have to handle. 3 can't do nothing, h can't do nothing. So I have here what? 2h cubed over 3, right? That is being multiplied by, I'll deal with the j's now. J to the negative 3 minus positive 1. And then that being multiplied by k cubed over 1. So that means what? I'll have j to the negative 4, right? So that means that that j is going to be in the denominator. So now I'll have 2h cubed k cubed all over 3j to the positive 4. Because if you worked it out here, it would have been j to the negative 4, and of course you carry it to your denominator back again, right? You all get through this?
Yeah.
Yes.
I have a feeling I'll leave this. I don't know if to believe that yes, right? So this here will go into this, so I'll have p to the 1. This here is 1 will go into this, so I'll have n to the 1. This here will go into this, so I'll have m squared. So now I have 4m squared n all over 3, and that's it. Nice. This is a whole bunch of negatives, and well, actually no, these go to 1. So if these go to 1, then I could just write them off one time by just 1, so that I cancel them with nothing. Right? So now I have 3 times x to the 3 minus the negative 4 times, and I could just take these guys and flip them to the denominator one time. 1 over y z. This is y to the 1, z to the 1. Right? And I skipping real steps here, by the way, so I hope that you are following. Right? So that is 3 times x to the 3 and 4 is 7. Right? So you see how this is a positive here? That means it'll stay in the numerator. If it had turned out to be a negative, then I would have put it in the denominator to make it positive. But because it ended up being a positive, it'll stay in the numerator. So that means that the answer is 3x to the 7 all over yz. You all got that?
No.
No? What do you do?
Oh, yeah.
You left the x's.
Yeah, like I don't know why, but I had 3x equals 3 divided by yz x equals 4.
Right. Yeah, but you had the y's in the denominator.
Yeah.
Okay. And well, we have our answers here. Let me see what they had for that last answer. Yeah, 3x to the 7 over yz. Right, so now we reach here. Wait, 90 questions. We finished a good bit in about an hour, man. So if we could finish all 90 now, then I'll send us home early, right? So with this one, I could say that b minus 1 is equal to 3 squared. Therefore, b is equal to 3 squared plus 1. B is equal to 10. Are we cool with that?
Yes, sir.
Nice. So this one here, I could say x over 2 is equal to 2 squared. Right? So x is equal to 2 squared times 2, which is 2 cubed. 2 2s are 4, 2s are 8, which is 8. Cool?
Yes, sir.
Right? Ooh, this one is a tricky one. Minus 8 negative 2a is equal to 0 squared. Well, 0 squared is 0. So negative 8 minus 2a is 0. Negative 2a is equal to positive 8. A is equal to positive 8 divided by negative 2, which is negative 4. Yeah? See?
Okay.
Yes, sir.
Same thing here. X plus 4 is equal to 0. Because 0 squared is 0. Therefore, x is equal to negative 4. Yeah?
Yes.
Yeah.
Alright, over here, r minus 3 will be equal to 5 squared. So r is equal to 5 squared plus 3. R is equal to 5 5s are 25 and 3 is 28. Right, with this one, you could just square both sides. So square, because look at what we do here. Remember, we square both sides, right? It's not that you're taking this and flinging it across. You know, we actually square both sides, right? And that will cancel off here, and then we have to square this side as well. So we've been squaring both sides all the time. So over here, you can just square both sides, and you would have just ended up with 2m minus 6 is equal to 3m minus 14. That's all. And now you can solve for m. So 3m, I'll put the positive 3m, and if I take this 2, it'll be minus 2m, and that is equal to negative 14 plus 6. Alright? Wow. So now that'll be m is equal to, where's negative 14 plus 6? How the hell, my brain dead? Negative, what? E? What's the difference between 6 and 14? 6? Negative 8. Okay, yes, negative 8. So 6, 7, 8, 9, 10, 11, 12, 13, 14, yes. Thank you very much. You all got that, by the way?
Wait, I had 8.
You had positive. Did you all know how to square both sides though?
Yeah, I squared both sides.
So what did I do here to get the negative 8? Well, I took this 2m and I carried it on that side, eh? So it was, I'll leave the 3m alone, so the 3m minus 2m Right? That had to be on once. Oh, I do something wrong. Alright. You know what? Let me do it properly with the steps. I see the error that I make there. So I'll leave the negative 6 here is equal to 3m minus 2m minus 14. And it was the 14 I was supposed to bring across here to get 14 minus 6 is equal to m. So m is indeed positive 8. Sorry about that. Alright. Good job for correcting me. This one is quite a bit tricky though. How did you handle this?
Okay.
Just square both sides, right? So you have 8k is equal to k squared. And now, instead of throwing the 8 across, you throw the k across. K squared divided by k. And of course, these will cancel. So k is equal to 8. Yeah?
Yeah.
Over here, you just remove the squares, or you square both sides. 1 minus 9b. So I'll bring the minus 9b across here. 9 minus b plus 9b is equal to 1. And I'll bring this 9 across there. So minus b plus 9b is equal to 1 minus 9. So therefore, 9b minus b is 8b is equal to negative 8. So b is equal to negative 1, yeah?
Okay.
Help me out. My brain is on fumes right now. 3 minus 2x is equal to 1 minus 3x. I'll bring this tree across here, and I'll take this tree and bring it across here. So that means that I'll have positive 3x minus 2x is equal to 1 minus 3. So x is equal to negative 2. Is that what you got?
Yes.
Alright. And then 3k minus 11 is equal to 5 minus k. I'll bring this k across. So you'll end up get 4k on this side is equal to 5 plus 11. So where's 5 and 11? 16 divided by 4, which is 4.